All right, ladies and gentlemen, today we are going to talk about lines of symmetry, or what we call rotational symmetry. And the idea with rotational symmetry is if I put a dot in the center of rotation, there's a center point around it can be rotated and end up in its back in its same spot. So here I have a star, and there's the point in the center. And if I rotate it a few degrees, it's back to where it began. And I rotate it around again, it's back to where it began. This is a figure that has some rotational symmetry. This right here is also a figure that it has rotational symmetry. It has a little less, because I can only rotate it twice in 360 degrees and get it to overlap. But kind of the idea with rotational symmetry is, can you rotate it and get it in the exact same shape? Here is a figure that does not have rotational symmetry. If I go on ahead and mark this as the top, it's not overlapping, it's not overlapping, it's not overlapping. It's not overlapping until we've turned it 360 degrees. So, appearing the very same or rotating onto itself. This can always be done with 360 degrees, like that last example. If the smallest number of degrees we can use is 360, it's considered to have no rotational symmetry. The other thing that you're going to talk about next time is a line of symmetry. And a line of symmetry is a little different. A line of symmetry says, if I start out with a shape like a square, is there a line that I could draw that basically, if I folded it in half, if I folded it along that line, it would overlap itself? So a square definitely has a line of symmetry there. We'll have a line of symmetry anywhere else? Absolutely. What about on the diagonal? If I fold my square in half along the diagonal, again, it overlaps perfectly, so that is a good line of symmetry. Altogether, how many lines of symmetry do you think you can find in a square? Well, it turns out that you can go through the middle of each side, from side to side, that's 2, and then you can go through each angle to angle, so a square will have 4 lines of symmetry. What if I show you a different shape, like maybe a kite? Again, a line of symmetry is where I can fold it in half and have it overlap. So if I fold it in half right along here, it is not overlapping. That is not considered a line of symmetry. But if I fold it in half this way, all of a sudden it perfectly overlaps. So this does have 1 line of symmetry. Coming to class next time, I just want to make sure that you know the difference between a line of symmetry, where you fold in half, and rotational symmetry. If I took this and I rotated this around, it's not going to overlap, it's not going to overlap, it's not. It doesn't overlap until you're back to the very beginning. So this has no rotational symmetry, but it has a line. A rectangle, it has a little bit of both, right? Because if I take it and I turn it, it overlaps here, and then I put it back to normal. So it overlaps twice. It has 360 divided by 2, so 180 degree rotation. And then it also has some lines of symmetry. You can go through side to side, side to side. Can you do the diagonals? Let's just double check before I write those in. Oh, if you do the diagonals, it does not perfectly overlap. So a rectangle only has symmetry through the sides. So it has 2 lines of symmetry. And then it has 180 degree rotational symmetry. So the big concept for next time in class is making sure you understand rotational symmetry and line of symmetry. It would be very interesting for you to kind of go through these and jot down what you were thinking, like an equilateral triangle. If I rotate this, it is going to overlap a little. I'm going to show you this example. It's like a fancier version of an equilateral triangle. And it's a fancier version because it's, a three-sided figure. And if I rotate this 1 time, it overlaps, 2 times it overlaps, and 3, we're back to the beginning. So this has rotational symmetry 3 times. In order to figure out how many degrees that is, we just do 360 divided by 3. And our calculator tells us this will overlap every 120 degrees that we rotate it. If we were folding it, we could fold it from 1 vertice through one side, from 1 vertice through one side, and from 1 vertice through one side. So this has 3 lines of symmetry. I just want you guys to kind of go through and guess on these. I'm not going to tell you until in class. I just want you to make your best guess. This is more broadly a regular in-gon, so that means for any particular side, not a given side. So I don't know how many sides there are. There could be 7, there could be 17. But in order to figure out the rotational symmetry, you would do your 360, and you would divide it by the number of sides in. And then your lines of symmetry, it's always going to end up matching the number of sides in. Thank you.